So what is data science, and why should students of sabermetrics care about it at all? Well, one reason to look at data science is that data science is sexy. It's hot. It's all over the place, and Harvard even said so. Jobs in data science are increasing. That's the reality. The field of data science is increasingly written about in the popular press. It's becoming a term widely used in academics and business. So this video will introduce you to what data science actually is. And it's one of the reasons for the popularity of this class. Many of the students in Sabermetrics 101 want to learn more data science. You could essentially say that this course, Sabermetrics 101, that BU is offering on the edX platform, is an introduction to data science, specifically an introduction to applied data science, the application being the game of baseball. So, what is data science? Data science is not just data analytics. The process of analyzing and summarizing data that we spoke of in the statistics track of this Module 1. It's not just statistics, the field of statistics. It's not just gathering and scraping and taking data that we can get from different sources. There's more to it than that. One fundamental thing you have to understand to be a data scientist is the structure of data, is how it works inside computers, how databases actually work. One of the reasons we spend so much time on designing and implementing the awesome BU SQL Sandbox used in this course is to introduce to students who want to learn more data science, introduce students to SQL itself so that we can learn more about how databases work and how they're structured. This includes the architecture of the database, how it's designed. The data architecture of the database is a key component to data science. And also, we want to talk about how these data are stored on computers, how they're digitally stored on computers. How do we actually get to the data and manipulate the data to help answer our own questions? How do we preserve the data? How do we keep the data around so we can get it at any time or keep it for posterity? The second point here is that you, as a good data scientist, you really have to understand the client's needs. In other words, what your customer wants. Who do you work for and what are their specific needs? If you don't understand the client needs, the data scientist will run into trouble. Let's use a baseball example here. Let's say you're a data scientist or analyst for a baseball team. Your client, the person you report to, might be the general manager of the baseball team. The general manager does not necessarily understand data science, understand databases or statistics, as well as you would, the data scientist for the organization. But you're going to have to understand what the client wants. You're going to have to understand in baseball what the general manager wants, what questions the general manager needs answered so the general manager can do their job in either trade acquisitions or free agent signings or drafting players that might be part of their baseball team. So you have to understand a certain language that the general manager and the baseball culture, the baseball business uses. There's a certain expertise that the client has that the data scientist also has to adopt. This is a very important piece of data science, understanding and being able to communicate with the actual client. There's also a concern in data science about privacy, about what to do with data that might be considered not for public consumption. What do you do with these data? How do you store these data? How do you redact the data for certain clients? It's actually an important consideration in database design, how to keep the privacy of certain data so that not all clients and not all users of the database get access to private information. And this is really just the tip of the iceberg. The data scientist is going to be a person who really understands an awful lot about the client needs how to deal with the client needs, and then how to structure those needs inside the database system that the data scientist designs and implements. The data scientist has to be good at statistics, data analytics, and understanding data modeling and analyses. And you also have to be very good at computer science and database work. So the data scientist has a lot of different hats that they put on to get their work done. Our last piece of looking at data science is this well-known graphic that describes data science. This is the Drew Conway data science Venn diagram. You can go to this URL and learn more from Drew Conway himself. There at this website, he talks more about his Venn diagram and what it means. I'll give you my take on the components of the diagram. So what we have here are the three major parts of data science. First, the hacking skills. The hacking skills described over here. The database skills needed to work with data, structure the data, clean data up that might be messy depending on what data you have and where you got the data. Second, you need to know some math and some statistics. You have to have math and statistical knowledge. How to model these data, describe these data that you might be collecting as a data collector. You also now have to know how to model the data, how to describe the data. You need to know some basic descriptive statistics so that you can answer some basic questions that the client might have or your colleagues might have as well. And if you really want to be a data scientist, you have to have an understanding of the material. You must understand the substance being talked about. This is essentially speaking in the same language as the client to gain an understanding of what the client might need. So in baseball, the substantive experience, you've got to know the game. You've got to know how the game works. You've got to know how sabermetrics has gone through its various stages, its history, and how baseball analytics has changed over the years. So you also need to be a statistician and good at math if you want to be a data analyst, a sabermetrician. You've got to understand some modeling, some descriptive statistics that allow you to describe data sets. You also need to be good at collecting data and organizing data to be a good sabermetrician or baseball analyst. And you've got to also start asking the right questions. So if you were a good computer scientist and had good hacking skills, and you were knowledgeable in statistics and math, you might have what Drew Conway calls machine learning. You're very good at the technical side of being a data scientist. This section here called traditional research, the idea here to keep in mind is sort of as the traditional PhD scientist. PhDs are well trained in modeling and statistics and describing their data sets, and they certainly have substantive expertise. So this is called traditional research, or traditional scientific kind of research here. If you've got the statistics background and you understand the field very well, you're very good at traditional research. This area here is called the danger zone by Drew Conway. This is the place where you might have some expertise in the field and you might have some computer skills to gather the data. With those computer skills and some understanding of the area, you might create, say, a new metric, a new statistic, a new measurement of something with your knowledge and with your ability to look at data and gather data. But if you don't know how to model it correctly, if you don't know the right statistical modeling to do to create good metrics, you're going to be describing things that other people might recognize as not being based on sound statistical principles, sound descriptive statistics, or sound modeling ideas. So, of course, the sweet spot here, the whole point of this Venn diagram is to get to the data scientist. That person with the right computer skills to collect and organize data, that person with the right statistical knowledge to model the data and describe and summarize that data well, and obviously the person with the right knowledge of the area under study to be able to ask the right questions and think about the data collected, and how it's modeled correctly. So you need to have these three components to really become a good data scientist. Remember, the word data scientist includes science, and we defined science in an earlier video in this module. Science is essentially having an intense curiosity about the natural world and observing it carefully. This observance part of science relates to the data that you might collect, the data you might organize, and also the data you might understand because you're the expert. So looking at the world, collecting data with your observations, finding data you're interested in, and asking questions about it. Stay curious. Use the right statistical models to help answer your questions. You need to be an expert in the field as well. You need to have the right expertise. So, being able to generate well-informed questions and then having the technical skills to be able to answer your questions. These are the key components of good data science. These three circles in this Venn diagram describes what it means to be a very good sabermetrician. So we're going to be covering data science and the elements of data science throughout this course, Sabermetrics 101. So, a reminder, Sabermetrics 101 is an applied introduction to data science, applied specifically to the game of baseball. And remember, if you get confused about all the components that you need to have to be a good sabermetrician or a good data scientist, refer back to Drew Conway's Venn diagram.